Assalamualaikum and very good morning to all. I'm going to present my articles together with the team. So this particular research is actually combinations from the two entity, which is University Malaysia Kelantan and another one is DOSH Malaysia, whereby I have to acknowledge the contributions of NIOSH in providing the funding to this particular studies. So after all, this is only a partial, not a partial one, but very slight results that is being published from the overall research studies. So I have to highlight it so that I don't want you to miss the information, because not many information that we can provide, because this one is a part of the research studies in the level of national level for Malaysia, in order for us to improve the performance of those workers in construction industry that working under thermal stress, mostly because we are in the tropical climate in Malaysia. So that is the things that I want to highlight first prior than I start the presentations. So this overall titles is optimization of thermal conditions of heat stress among the workers and their performance in the industry environment using the responsive method. So what I'm trying to do is that this particular research studies is we know that in the reality of the construction industries, the worker have been exposed a lot, especially in Malaysia. We are being exposed to high temperature, high relative humidities, and some of the studies has revealed that when this kind of workers being exposed to the high temperature and high relative humidities, they are significantly being impacted by the heat. They might have heat-related illness, such as the heart failure. Their focus and attention to the work have been interrupted for a significant period of time under the heat stress. Not only changing their behavior or changing physical looks of him, which is your skin might darker as compared to those that work in the office work, but it's beyond than that is the impact towards their productivities, their moods, and of course to the quality of work that they want to do. So then there are a lot of defects, and because what? Because they're working with high heat stress, their focus to what works is reduced. All right, so they couldn't focus much. So therefore, you can find out a lot of defects in most of the buildings, and the things will impact the overall productivities. So there are a lot of studies previously focusing on the use of VO2 max in order for us to determine the human performance. All right, so VO2 max is a part of the parameters in terms of oxygen intake. When we perform the hard work, definitely the increasing of VO2 max, all right, significantly correlate very well with the numbers of the frequency of the weight, the numbers of loading that we are performing. So that is the use of the VO2 max. Basically, it's about the oxygen intake. We're measuring the oxygen intakes, all right, with the temperature. So this is a two variable that I'm trying to conclude in this particular presentation, whereby we measure the temperature and we measure the VO2 max. And then with these particular parameters, we're trying to optimize it by using the responsive method. Of course, the responsive methods have been used a lot in various manufacturing sectors, but not in the human integrated towards the work. Very rare. I couldn't find out that articles that focusing on the use of responsive method in order to optimize the human performance instead of the machineries. Yes, they do have it. So summary of the finding on the application of RSM, some of the researchers have come up macam yang most of those researchers here lah, So I highlighted the use of RSM, but not even a single one that utilize RSM for the optimizing the human performance. So the objective, of course, we want to optimize. Let's say on what temperature level that these workers are actually optimally can work with. For those in the working under in the construction, in the outdoor, and also in the indoor too, which means the structures of the building is already there, so they need to do the work internally on inside the building. So this particular experiment was conducted in the chamber in IOSH Johor, whereby we do have a simulated chamber. We do have conducted the experiment and instrumentation, and we evaluate the performance as well as design of experiment by using the RSM. Alright, so we do measure the relative humidities and temperature. Alright, so we have set up it as level 1, level 2, and level 3. And we do also measuring the heart rate as well as VO2 max, what we call a volume oxygen uptake. Alright, and then we simulate the workers, the humans under this level 1, level 2, and level 3 of the relative humidities and temperature. So as the result, we finally figure out that by using the optimization, we finally figure out that the optimal value temperature can achieve for certain work that we have selected is 24.24. So this one is actually correlated well with those studies, previous studies and the guidelines and the ASHRAE related to the human comfort. And for the optimal value for relative humidity also even stated around 45, which is also highly correlated to the findings from the past studies. So this one is actually the combination for the indoor. And when we take a look to the outdoor, we finally figure out that the optimal temperature also equivalent to the dose that work in the indoor. But then some things that difference is that we found out that the optimum value for RH can be mitigated at 75%. So which means that those workers that work in the outdoor, they also can be performed very well under the temperature at 24. But at the same time also we have to maintain the relative humidities at 75%. So that is the values of the relative humidities that we need to achieve when we ask the workers to work outside of the buildings. All right. So we finally figure out that the RSM is able actually to optimize the overall of human heart rate and VO2 max by multiplying the effect of the temperatures and relative humidities in the particular case. So another research study later on need to be conducted in order to find out the recommended way on how we can mitigate this kind of worker, because the worker will work from 8 to 5. So how we want to optimize the temperature, maybe with a certain utilization or designing experimentation, designing the clothing. So that is one thing that we are currently ongoing to look to that particular matters. So I think that's a very basic one presentations for this article. Thank you very much for all your attention.